this. Okay, so we were just doing one of these. Anyway, cosine is x over r. So also at the top, you put this on your test, sir, kicks or ticks. What's that? That's just a translation from SOHCAHTOA to coordinates. So if you wanted to put SOHCAHTOA up at the top, that'd be okay. But when you don't have a triangle, you need sir, kicks or ticks, and we'll talk about one of those. So fine, this could have been SOHCAHTOA. Yo. You could put A, O, and H. Remember, this is the reference angle, the angle that we play O, A, and H, and label those sides. Anywho, 1 over root 2 is root 2 over 2. Doing your homework, you've seen this numerous times. All right. Well, I know what I could have done. Darn it. I know what you could do at home. I could assign a quizzes. I just had second hour. I know you'll be mad at me. Maybe I'll put it there for practice, and you don't have to write anything on it. A quizzes that goes over these little trig questions. Might be a good idea. And then let's pick another one. Cosecant. Let's say, I don't know, 5 pi over 6. Doing different ones than the other hour. First of all, what's an over 6 in 5, 4, 3? What's the reference angle? 2, 1, go. Watch your counterparts here. Got a lot more people this hour. Good. Last hour, about 5 people were answering. So, but that's enough. And everyone knows that's a 30. And then in 5 seconds, what quadrant is it in? 4, 3, 2. Hopefully you're not looking at the unit circle. 1, 0. Go. What quadrant's that in? Ooh, a lot of different answers. I like it. 4, 3, and 2. And quite a bit of each. Interesting. So let's make the adjustments. This is 6 pi over 6. So make your change if you answered this incorrectly. Okay, if this is 6 pi over 6, where is 5 pi over 6 land? Why is it 6 pi over 6? Because this is pi. Right, no one's making adjustments. Okay, the answer is actually 2. This is 5 pi over 6, which is a pi over 6 short of 6 pi over 6. There's some adjustments. Okay, so knowing it's a 30 degree, and then knowing where it lands without a unit circle in front of you. All right, and that's how you do it. You compare it to pi or 2 pi, common denominators is all that's going on there. Then if you don't know that this is 1, this is root 3, and this is 2, you're severely and totally behind, and I don't care about saying it. All right, we've actually been doing this too long. This is about 3 weeks old, the idea of a 45, 4590 and a 306090, what are the sides that we should know? So, yeah. All right, and I went back to SOHCAHTOA instead of sir, kicks, or ticks, but I'm going to go back to sir, kicks, or ticks. Cosecant's related to sine. That's all you had to know about that. So this is r over y. So that's what I always do in my head. I think sir, and then I do, okay, it's the reverse of that. So r, which is h, over y, which is yo, o, 2 over 1 is 2. And then don't forget about the negatives, even though it didn't happen in this question for the final answer. But don't forget that you get negative side measures here. So up at the top, maybe one more thing to remember. Pi over 6 is equal to 30 degrees for those that did not type. Pi over 4 equals 45 degrees, and they do. And then we extrapolated further that anything that is over 4 will end up being a 45 somewhere. We just got to find the quadrant. Then the last one, I won't do one like this. Pi over 3. Well, maybe I will. 60 degrees. Okay, but then I could have questions like this. Cotangent. And I can flip-flop between degrees and radians. Now I'm in degrees. Just kind of gave it away. What is the reference angle? Put that in the chat. In 5, 4, 3, 2, 1, 0. What's the reference angle? Uh-oh. Not so good with degrees? Or we just don't want to answer anymore? Ooh, we got a 30. I got a 60. Got a 30. Got a 30. Alessandra, that's what I was worried about. Your one question, you went off of the y-axis when you said 270 plus another 45. That's what I was worried about. 120 is here, which is actually 60 away from the nearest x-axis. So the reference angle is actually 60 for those that answered that. So good, I'm glad I'm going over this, so that we make sure we don't make those mistakes. Remember, this is coordinate trig. X comma y is up here. So you do x first, then y, then come back to the hypotenuse. Side opposite 30 is 1, side opposite 60 is root 3, side opposite 90 is 2. This is a negative. We go back to circ or ticks. And cotangent is x over y, because cotangent's related to ticks, but it's the reverse. So it's x over y, which is negative root 3 over 3. All right, and then just some other points to make. What's, what if I ask trig of, say, 270? Sorry, I don't want to go too long on this. Trig of 270, oh my gosh, I can't write a 7 here. Here's 270, which is the same as 3 pi over 2, right? What's that coordinate? Put that in the chat in 5, 4, 3, 2, 1. Go. Good, look at all of those. Awesome. Ooh, I like it, Jad. Hey, Jad, weren't you the one that said 0, negative 77? Or was that somebody else? Was that Sebastian and Sebastian in here? I can't even see. I always get confused who's in second, who's in third. But actually, we've been doing 0, negative 1 to make it easy. If you did 0, negative 2, then your R would be 2, and it ain't no thing. Right? And then you could do circ or ticks of any trig that I asked for this. So let's just throw one in there. Let's say sine. So what's sine of 270? Y over R, which is negative 1. This one you have to do circ or ticks. There is no triangle. And then one more thing, any of the coordinate trig, which we did do in one of the days. I forget which one, but I did 2 different questions. Either given a coordinate, do all the trig. So you draw the triangle the same, it's just not a 30, 60, 90, 45, 45, 90. Or given sine of theta equals 2/3. Theta is in quadrant 1. Find the rest. Okay, I'm just gonna, put it that way. Okay, well, question like this, zooming in as much as I can. This is like almost giving you a coordinate, but we have different letters here. Since it's sine, that is y and that is r. Here's theta, which you never find. Here's y, which is 2. Here's r, which is 3. This is not a 30, 60, 90 question. This is not a 45, 45, 90. You never find the angle measure here. All right? But what you need to do is find x. To verbalize, you find x by the Pythagorean theorem. So it's x squared plus 2 squared equals 3 squared. 3 squared is 9. I'll have to subtract 2 squared, which is 4. 9 minus 4 is 5. And then I'd have to root both sides. So there's x. From there, you could find the cosine of theta, even though you never find theta. From there, you could find the tangent of theta, even though you never find theta. Tangent's y over x, which is 2 over root 5. Know how to rationalize. And then secant, cotangent are flips of that, and cosecant's flips of sine. So you remember those. So it either can be expressed like that, or do a terminal side passes through this coordinate. Well, you draw x, you draw y, you find r through the Pythagorean theorem, and then you do the same. Okay, so just warning you about what's on the quiz when you walk in, and then we're going to move on with circle attributes that we're going to start today. Well, actually, we started on Tuesday, trying to get the specific day. Okay. Ooh, getting too close to the camera. Big face right there. All right, so knocking around in my head like what to do and share with you guys here today. And I stole a picture from the internet, but it's really based off of what I told you to do here. Read this page, something I stole from the internet again. And at the bottom of the page, there was this video, which I directly linked right here. It's just the guy talking about the parts of circles and some other things about circles that are nice to know. So I found this picture on the internet on various websites. So someone made it and then it's been used over and over again. The only thing that's different on the second picture is they denote what is an arc. So they have that added to this. So some things to look if you're writing this down. This is really what the guy already did for you on, you watched that movie Tuesday or Wednesday. One other thing to mark down is a little special thing here. This is called a point of tangency. This is where the tangent line crosses the circle once and only once. Notice this diameter, but more specifically, this is a radius. We should know a diameter is 2 radii. I think that's said in the video. I watched many videos to try to pick one that was nice and short. But we know that's a radius. Notice what happens with that radius and the point of tangency. They are perpendicular. So I think that is going to be something we'll hit next week, some other attributes, but it's nice to see that right there as well. Tangent lines are very special, right? They actually are, they're just very special. They're the basis for, if you ever heard of a derivative in calculus, it's based off of tangent lines, really how a derivative is derived. Then notice the difference between a chord. A chord is a segment as opposed to a secant line. So this is a segment, meaning it has a starting and an ending point, whereas a secant, I got to kind of write this crooked, is a line. Sometimes it looks like a ray with what we're going to have in our notes, but that's what a secant line is, how that's a little different than a chord, and much different than a tangent line. And I just noticed, these are 2 trig words. Is there any relationship between the trig tangent and a tangent line? I don't really know. I don't have an answer to that. I don't think so. So it's kind of an unfortunate, thing there. Same thing with secant and trig. I don't know how that happened. That's an answer I cannot give you. There may be, not really sure, but there isn't in terms of, we're not doing trig on the circle. It's just the name of an idea. So sorry, I don't know that, but I don't think there's a relationship. Just an unfortunate use of the same word in 2 different completely things. But I may be wrong. Maybe there is some sort of relationship. Okay, so you see all the same stuff over here. Not as a colorful drawing. I just did that because of arcs. Okay, if you weren't able to print this, I have this twice because I want to do 2 different things with it and it gets too messy. And then me doing this the way I'm doing, you're going to have time to keep up if you don't have this printed out. I did make this own drawing myself a long time ago. Let's call this circle O. That is my attempt at a dot on my old program. I think I just used Microsoft Word. Now let's just go ahead and go around the circle and name these things. I don't think I named AB as a chord. Maybe I did last time. So just go around, make these letters the same so that we all have the same outcome here when I start labeling stuff. Okay, and I don't know if I want to do, there's going to be a lot of examples of each one of these. For the first one is, let's maybe number these. I didn't number them last hour. Radius, or plural is radii. Okay, so notice our notations as well. So some of this may come out of nowhere. You may have never heard of this stuff before. You're just going to have to memorize vocab. So some radii are OA, segments, OB, and you could say BO or AO, GO or OG, and OC, I think are the only ones that I see there. So I can mark all 4 of those. Those are all radii. Okay, and then it's simple, what I just said about a diameter. The classic or definition of a diameter is it is a chord, but it's a chord that passes through the center. And it's the longest chord in a circle because of that. So, but we only have one, and that is GC. So the next thing we'll write is, what are some chords? Really shouldn't call GC a chord, because that is a specific chord. More specifically is a diameter. We want to call it its most specific thing. The only chords I see are FD or DF and DE. I don't know how else I could do this. Going through definitions, naming, just knowing our stuff. But when we get to arcs, that might be new in how we label stuff. Okay, so we got chords, diameters. We don't really have any secants or tangents because we don't have any lines that go forever. So we'll just leave that alone right now. So none of these are secants or tangents. We're not going to put them in there. So the next thing is what is a central angle? And I'll write a short definition for that. And again, if you've seen this before, fine. But a central angle is an angle whose, very short definition, vertex is the center. And then I'll write a couple examples, just remembering and reminding you, how do you write angle measures? I don't know what you've done geometrically. So with the vertex at the center, some angles that we have. Now we have a whole bunch of them. I don't think I'm going to write them all, because I have this one, I have this one, and I have this one. You may think there's only 3, but you're wrong. You have this one, or you have this one, right? So there's at least 5 that I see there. And I'm not going to list all 5. I'll list a couple. So GOA, for instance. Notice O is in the middle. The vertex must be in the middle for an angle measure. Some people, I did think, messed that up when we did some angle stuff. AOB. And then I'm going to do one of those bigger ones, like AOC. That is also considered a central angle. And then ... Just we're saying that's not the only ones. We have a few more. Quite a few more. Okay. And then on the next page, on this drawing, we'll talk about relationships. That's why I have a second drawing, because I don't want it too marked up. I want a drawing for vocab and how to name or label these things, and then some angle relationships. So we'll hold off on that, what we know about central angles. Then the other thing is an inscribed angle. This can be tricky when we get into like finding some missing variables. Inscribed angle, that is an angle whose vertex is on the circle, much different. I'm going to speak like a caveman here. Vertex on circle. Okay, bad English. I just don't want it. It's short and sweet. Okay, especially in our environment that we're in. We just want to get you to brass tacks of stuff here. All right, so we got diameter, chord, central angle, inscribed angle. We'll talk about those relationships on the next page. And then here, we're going to talk about arcs and how we name them. There is something called a minor arc, a major arc. We're just going to be talking about names, in a semicircle. Now, I'd be stupid to ask in the chat, what's a full circle? I think everyone knows a full circle is 360 degrees. So when we look at this measure, what's that measure? You know, don't even put it in the chat. We should know that that's 180. But then, well, maybe I'll jump right to this then. So then what can we say about this arc here? So arcs are actually going on the circle itself and naming what is that like compared to the degree measures of the central angles. Now I'm kind of leaking into the relationship of a central angle and the arc it intercepts. What I've colored right there is a semicircle, okay? So this arc can be named, and actually I'm kind of jumping ahead of myself here. I don't really want to call it GC because I want to know which half am I talking about. So my opinion is we should name an arc with 3 letters if it's a semicircle to know which half I am talking about. But the real thing is, look at that symbol. It's not a segment symbol, it's an arc symbol above that. Actually, I want to erase that highlight Okay, I have to rewrite that. Now I want to highlight this. Or you could have arc GEC. See, that's a difference. That is this half, right? And that is labeled as a semicircle as well. And actually, the arcs are both equal to 180 degrees, just like the angles that intercept them. So what's a minor arc? Kind of jumped out of order there. A minor arc is any arc that is less than 180, less than 180 degrees. And those just require two letters, the most direct distance. There's a million of them in here. GA, AB, even AC. We know that is a minor arc because the angle that cuts it is less than 180, right? And that's kind of leaking in the relationship of an arc measure to its central angle that cuts it. And then, I'm tired. ... You can name a million. FE, FG, DC, ED. There's so many of them. So what's a major arc? A major arc is greater than 180. This requires something different because think about it. Here's GA. If I wanted to name this arc, well, I can't call that GA because GA, two letters, it's the shortest distance between those two letters, or the shortest angle measure. That must be a minor arc. So to name that green arc, I would need G, the start, and then any one of these letters, any of them. So I'll pick D. And then the ending letter. So the starting and ending letter must be the same, or it must be, concrete of where it starts and ends. The other letter is just what direction do you go. So I could have picked F, E, D, C, or B in the middle, and it wouldn't have mattered. This would still be the same mark. By the way, the yellow and the green together add up to 360, right? And that's what you're going to know about major arcs and minor arcs and arcs in general. I don't know. Another one would be ACF. I just made up one. ACF. Okay, starting from A through C to F through C, and then end at F. Of course, that's greater than 180 degrees. That's why it's called a major arc. And then we can do this all day long. Ain't no thing, chicken wings. I'd go for some chicken wings right now. I don't have any in the freezer. It's too bad. Okay, thinking about lunch. Same drawing again. We call this circle O. And then I've already talked about a couple relationships. A, B, C, D, E, F, E. I think that's it. Kind of in the way here. Okay. Put some measures in here. Let's say 55 degrees is this angle measure. And then let's say this arc from here to here is noted as 62 degrees, let's say. So the arc is there. Okay, then what you're going to see is, and I've already talked about this relationship here, that an intercepted arc is equal to the central angle that cuts it. So angle BOC, that measure, put measure, is equal to the measure of arc BC. Just had to get my letters there. So arc BC will also be 55 degrees. So this is 55 degrees. This arc measure is said to be 55 degrees. Okay, and I think maybe you've known that before. I don't know. All right, so then that means that if this is given as 62, then the measure of arc AB must therefore equal the measure of angle AOB. So that means AOB is also 62 degrees. And that's how you play around with these, some basic questions about that. Hey, what's arc GA then? What is arc GA? Put that in the question. I'm sorry, in the chat. What's arc GA in 5, 4, 3, 2, 1? Go ahead. Good. GOA is equal to arc GA's measure, and you got 63 because these should add up to 180. Because we know this is a diameter, so it cuts the circle in half. So that's why that would have to be the case. So these are the kind of things you play around with. The only thing I want to cover after this, then try to get to, well, I have actually 2 more concepts to shove at you here, and I don't know if I have time to derive it, but what is this? Well, let's take a look at this real quick. And let's draw a new angle in here, but just look at it. Don't draw it yourself. Well, we know that this angle I just drew, angle FOE, is equal to FE. But imagine, just listen to me. Imagine I take O, and this is a rubber band, and I take O and I stretch it and pull it to D. What is angle EDF compared to angle EOF? Is it bigger or is it smaller? Think about a rubber band. So I'm taking O, pulling it, and then pulling it down to D where it's still tethered to E and F. Is it bigger or smaller? Put that in the chat in 5, 4. Is EDF bigger or smaller? 3, 2, 1, go. Oh no, oh no. So if I pull it, what does the rubber band do? You know, here it is on O, and then I pull it, the rubber band closes, right? And that's what I wanted you to understand. So angle EDF is actually smaller than EOF. I want you to understand that what a inscribed angle, what happens compared to its intercepted arc. Actually, the relationship is, it is half of the arc that it intercepts. So what EDF is, angle EDF, is not equal to the arc it cuts. It is equal to half of the arc that it cuts. So that's what you need to understand for what's called an inscribed angle. So again, these were the things I was thinking about, like deriving, you know, some of these formulas, where they come from. So I'm going to erase this one because it's really, you know, that's what I wanted you to, as a kind of a deriving the formula kind of thing. Where did the half come from? I don't know. You're just going to have to accept that it's true, I guess. But it's definitely smaller compared to an inscribed angle hitting the same arc. So better make sure of that one. Okay, then the next ones I'm just going to shove at you, okay? They're kind of related to some things, a combination of stuff. First thing is, let's label this. Put this in the chat. What are these 2 things called for a circle in 5, 4? Come on, just answer questions. 3, 2, makes me feel good. 1, 0. What are those called? Nice. Awesome. So what I call these are chord angles. So my plan for today was, let's get all the angle relationships taken care of. So we're going to proceed further with some more formulas about angle measures compared to arc measures. So we have central angles equal to the arcs. Inscribed angles are equal half the arcs. Now with the chord angle, well, we got to name this again. We're going to call this circle O, but that's not an inscribed angle. A, B, C, D. I'm sorry, not a central angle. So I need another letter, E, that is not on the center. It's off. Okay? So we got to pick an angle measure. And the angle measure I'm going to pick is this, angle AED. So it is this angle measure here. First of all, understand that this angle measure and this angle measure here are equal because they're vertical. So that's number 1. Those 2 angles are equal. We do have to look at both of these angles to get what the measure of AED is. So AED does cut this arc. The only thing I can tell you is AED is not equal to that arc it cut because it's not a central angle. It's moved away. So it's not equal to that. So what is it equal to? Well, here comes the formula just shoved in your face. You got to get the other arc of the vertical angle that it cuts, and AED is equal to half. Now, it's not just half of this arc. That's if this was all the way down to here, if it was an inscribed angle. That's kind of like what I want you to think about. So what it is half of the sum of these two angles, or arcs, the average of these two arcs. So not quite an inscribed, not quite a central. It's a little bit off center. So we got this special formula that tells us what that measure is. Okay, and you're just gonna have to lock it in, all right, and just take it as a formula that I have to memorize without any deriving of it. Okay, hate to do that. I like to show you more what's coming. I tried to show a little relationship between central and inscribed, and it's a little in between the two. So you got a really different formula you got to use here. So I made a management decision to pick this angle to be the one I use. So you get the two arcs that they cut, and if you have those two measures, you can find that angle. And then let's do it again. Ooh, this didn't go so well in the other hour. Okay, real quick, draw that. And why are all three of these here? Because all three of these have the same formula. It's actually going to be really nice. Well, what are those called? This one right here. What's this called? And it goes forever. And what's this called? And it goes forever. Oh, you already got it. Good. So Alessandro already put it. Good. This is called a secant angle. So this is angle day. What's this one called? Of course, this is called a secant. Should go forever. But what's this other one called? 5, 4, 3, 2, 1 on the second one. What's this called right here? Nice. This is called a tangent secant angle. And I had an idea to try to get you to understand something on this, but we're at 10:58. I guess I do have 20 minutes. I feel like I'm doing better than the other hour. Then, of course, this is a tangent. All three of these have the same formula. So that's why I'm putting these three together. Okay, so I'll move this back in case you haven't taken notes. Just real quick. Boy, got to draw a lot of circles today, right? Hopefully you're good with that. Sometimes I get a good one, sometimes not so much. Do the best you can. All right, and then you'll get to see these as I break this down further. Because here's what I'm going to do. I'm going to compare this to like an inscribed angle. So I'm going to put an inscribed angle here that hits these points. Darn it, I wanted to go forever. I'm doing this because then when I grab it, it grabs the whole drawing. Watch when I grab this and I try to move it to where the secant angle is. Watch what happens. Watch what happens. See these points here? Watch what happens with this angle as it goes out. See how that arc gets bigger that it intercepts there? All right? And the point that I wanted to make was the following. Like if I extended this out here, then this angle is not equal to the arc it cuts. You know, it's too big. So this is too much here. So it's not just half of that big arc that it cuts. And the point I was going to try to make that this too big right here thing is actually equal to that right there. All right? So I was going to try to compare this to an inscribed angle. What happens when you take an inscribed angle and turn it into a secant angle? The big arc that it cuts is too big. So the angle is not half that. We have to do a subtraction. Okay, and if you didn't understand any of that and didn't like any of that, good, then ignore it and then memorize this formula. So let's put some letters here. Let's say, I think I put X. X marks the spot for this. Then we'll just do the old classic A, B, C, D. This secant cuts two arcs. And the whole big shindig that I just covered right there is that arc is too big to say this angle is half of that. You got to subtract that part. So angle X is equal to half again, because there is a relationship with inscribed angles, but there's a change. And it's big arc, CD, minus small arc. That was my, moving the inscribed angle to a secant angle description. You don't like it? Then just memorize. All right? And guess what? it's the same for this, but I'm going to mark this one a little bit better. A, B, C. So this arc is the big arc that the tangent secant hits. This arc is the small arc that the tangent secant hits. So in this case, angle X equals half. Now, you know what? AC is a minor arc. When I connect those two, it's not quite a diameter. So all I'm denoting is 2 letters is fine. Remember, 3 letters for a major arc. All right, and then the last one, it's the same, except I do need an extra letter. Let's put AB, but I need a C out here for naming a major arc. This is definitely a major arc here, this one. So the tangent cuts this arc and this arc, which, yes, is the full 360. That's what's special about a tangent situation. Many things are special about it. But angle X is equal to, again, half, but I need a major arc. That's why I had to add that 3rd letter so I know that this is a major arc. Minus AB, which is a minor arc. Woo! Okay, let's not overdo it. This is why I'm shoving all this at you. This is related to an inscribed angle in a way, but how things change and move. So central angles are equal. Inscribed angles are half the arcs they cut. Chord plus secant through tangent minus with that half in there. And then that's what you're going to have to separate in your brain and have this memorized. Really not too bad, as far as that is concerned. Okay, and then we're at 11:03, which is fine. We're going 11:20, man. You better do a jumping jack or whatever, get yourself all loosened up. Okay, if you didn't print this, then go ahead and give you a chance to write this down. I'm going to take a drink. Drink all my water between these 2 periods. Really thirsty. We'd have questions like this. You do have to have a drawing. So the drawing's here, but then they make you label it. In circle S, there we go. Measure of ER with an arc on it is 38 degrees. You mark that as 38 degrees, maybe put a little mark there so you know that that's that arc measure. And an OT is, 121. This is a basic one. Okay, do show me the work. Very simple. So remembering what this is a secant. So OUT is this angle measure. So the measure of angle OUT is equal to half big minus small. That's all you have to do, and then you calculate. Ain't no thing. Chicken wing. Stop saying that, Mr. C. I think I'm going to have some chicken rings. Anyone ever have those? Chicken rings? No? Oh, Evan, give it a whirl. All right. And then we have a tangent. Feel kind of silly that we're doing this, but you know what? You have a diameter. So they do give you the measure of, sorry for going over this fast, but circle M shown. XE is a diameter, so give a chance to draw it. So I wanted it, wish I could hand you a printed thing, but we're not in school. XT is 132 degrees. Kind of like doing that on the marking there too, just to make a note to self. All right, and then because we're short in time, let's close the chat, or not ask you chat questions, but everyone should know that since they call this a diameter, the green and the red, if you can see the green I just marked there, adds up to 180. So this would be, did I do that wrong last time? I think that's 50 would be 148. I'd like to see what I did. I just said 58 on accident. No one said a word. Okay, 48 plus 132, that's 180, right? 170 plus 8 plus 2, yes, 180. So this is actually secant tangent, so it's the same rules. And I don't know why they say draw a chord that connects these. You don't really need that. I guess what they're trying to do is show that this is like some sort of triangle or something. or there is something else I could say about this, but I'm going to leave that off for a second and then show you a relationship here. So really what we could do to find XUT is half big minus small. All right, so, oh boy, so bad at math. So 30, so that's a 16 left over. So is that 84? Half of 84 is that 42? Can't think. Is that 42? Is the answer 42 for this? Anyone? No, everyone's just looking at me. I can only see 6 people. Am I wrong on that? 132 minus 48, isn't that 84? And then half of 84 is 42. Thanks, Emily Ann. I can see you. Ooh, you guys don't know who I can see, though. Scary. Okay, I'll just leave it at that. Not go into it any further. We don't have the time anyway. 11:07. I think we're okay with this one. That's just a secant again. They add some other measures there. A full circle is 360. Another secant. Let's get to my next page. Let's look at some of these. Another secant, another one. These are just pretty basic here. So I just like cut something from our old stuff. Let me just do 11 real fast. So real easy. X is the angle itself. All right. So it is angle equals half big arc minus small arc. So secant minus. All right. And it is these two arcs that are marked. So these are pretty basic, pretty simple questions. And I probably have to ramp it up a little bit like later, but I just wanted the basics in your homework as well, just to get the ideas, because I felt like I was trying to throw a lot at you today. So I don't think now that I look at it, I don't think it's too bad. Okay, let's do this one, 14. I'm going to pop around all over the place real quick. Chord, X, arc. Couldn't be anything here. 5, 4 for the drawing, 3. Ignore the number, just call it an example. I pulled it from an old worksheet. Then this one's pretty basic as well, but it's X equals, it does cut this arc, and its vertical friend here cuts this arc. So this is flat out, plug in the numbers. But it's plus, and that's what you have to understand. It just is. You have to memorize that. Okay, let's get some more better ones. Ooh. Okay, so what's more better? Good English, Mr. Samuelis. Hey, let's put that in the chat. I said I'd close it down. Let's open it. What do you think X is? This is always interesting. We always get 3 different answers. Multiple choice. It would either say 80, 40, or 20. Interesting. We already have a 40. Does everyone agree with that 40? Got a 40, got a 40, got a 40, got a 40. This is hilarious. John, how dare you go against the grain? John put 80. Boy, that's weird. Wait a minute. Emily Ann put 80. Are these 3 weirdos, 4 weirdos, or do they actually have the right answer? Remember, sorry for calling you weirdos. You're not. You're right. I'm not saying anything that people got it wrong. Remember that this is equal. So that would be X if this was a central angle. And again, I cannot overemphasize the rubber band thing. Say I took that vertex and I pulled it back to A. Well, then the central angle closes, all right, and gets smaller. So actually 80 is correct. This is half of that, so this must be double, okay? So it's not a central angle, so it couldn't be equal. But then sometimes people flip a coin and put 20. And they think that the relationship's reversed. That's wrong. You're doing the wrong, idea there. Again, I want you to compare it to a central angle and then know that it's actually double in that case. Am I boring you, Matt? That was a big yawn. Yes, I can see you. Okay, I do want to cover this one and then maybe one more after this. We go to 11:20, right? I know that. Okay, this is weird. This one, you probably, if I asked you, what would you call this, you would get it wrong. Because you initially might say it's a chord tangent angle, but I don't have that. There's nothing that says chord tangents out there. And this angle actually just cuts one arc, not 2. So that's the arc that it cuts. This is strange. And then the only thing I can tell you is this actually has the attributes and most closely is considered an inscribed angle. It's because, look at the definition of an inscribed angle, its vertex is on the circle. So yeah, this one is just half of 230. But a lot of times when you see that, people don't see it as an inscribed angle. They don't get it, but it actually is. So it is 115 degrees. So when you have a chord attached to a tangent line, it actually emulates an inscribed angle, which it is half the measure of the arc that it cuts. Okay, so that one's tough. Let's see something like this. Okay, this one's kind of fun to go over. Maybe I could do two more. And then sometimes we could be a little bit better with the algebra, you know, like a little bit tougher, like having multiple x's. Probably have that when we deal with the side measures of these particular scenarios. But okay, so I have a 45 there. I have 122.5 just arbitrarily up here. And then I have to find this x. So really, as a problem solver, you should understand that I'm going to have to use this to find this. And I'm going to have one of these two angle measures. So I'm going to have like that angle or the other one across from it. All right, so I can use my formula correctly. So real simple. What's from here to here? The answer to that, don't even put it in the chat, is 180. So this angle measure is 57.5, I think. Okay, so you just have to do a little extra. Right, 57, 67, 77, 79, and then add the 0.5 is 180. But then here's what happens. Putting the things in the right spot for the formula. It is the chord angle, and that equals half of the two arcs that angle and its vertical counterpart cuts. And it is a sum. Okay? So just understanding what I need to find through what's given here, then go from there. And then problem solving skills, instead of distributing the 1/2, I'd multiply both sides by 2 so I don't have to distribute. 5700, is that 115 again? I just got the last question. Hope I did that one right. 115. Not related. And then subtract 45. Very simple. So dealing with that. Subtract 45. I think that's 70, right? So x equals 70 or 70 degrees. Okay? And then one more. Last one. Where's it at? Where's it at? Yeah, I think this is the one I did. Okay, so be careful on this one. 40 degrees is marked there. X is this. 96 is this. So we do have all the parts I need. There's nothing else to find, but just to know where everything goes. Secant angle equals half of big arc minus small arc. Of course, we know x is the smaller arc just by the drawing. This one you have to trust the drawing. So definitely 96 minus x, not x minus 96. Multiply both sides by 2. Subtract, not add. This minus sign is on the x. Good students do that all the time. They add 96 just because they see a minus sign. That's algebraically not good. But negative 16 equals negative x, so divide by a negative, and then you get 16. And you can't say degrees on that, okay? So just simple algebra on that, but just knowing where the parts go on. Okay, so I felt like we've done a lot. 5 minutes shorter than the other period, that's good. I don't feel like I have to do all of these. You know, if this is a tangent, why is he still going? And this is 250, then this must be 110 because a full circle is 360. Then 1/2 250 minus 110. So things like that put a lot of stuff together. And all the other stuff is redundant. It's all good. So going to the calendar real quick, I did want to show you that homework. Real basic. First page is just vocab. So got this from my old stuff because I felt like, you know, there was a lot of information here today. Vocab. And then, you know, more of the same, these questions that I expect you to answer that are standard. Okay? All right. I think we're good. You can take off. I'm going to go make my chicken, and you guys have a good lunch just like I am.